The modern world did not appear by accident. It was built, layer by layer, idea by idea. And some of the deepest foundations were laid in India. Before Europe awoke from its dark ages, before modern science had a name, before universities crowned their first scholars, there was a civilization asking questions about infinity, about surgery, about atoms, about consciousness. And yet, you were never told. You were taught the outcomes, but not the origins. This is the story of the knowledge that shaped the world and the silence that followed it. This is the story of ideas born in India that went on to shape humanity itself. Zero. It seems almost too simple to be revolutionary. A circle, an empty space, a placeholder for the absence of something. But without zero, modern mathematics does not exist. Without zero, algebra does not exist. Without zero, calculus does not exist. Without zero, binary code does not exist. Without zero, computers do not exist. Without zero, the internet does not exist. Without zero, the phone being held right now does not exist. Everything, every single technological achievement of the modern era rests at its foundation on the concept of zero, and zero was born in India. This is not a romantic claim. This is documented mathematical history. The philosophical groundwork was laid in India through concepts of nothingness that were central to Hindu and Buddhist thought long before the mathematical symbol appeared. The idea that nothingness is not an absence of reality, but a state in itself, that zero is not simply nothing, but something with meaning and function, was deeply embedded in Indian philosophy. But philosophy needed to become mathematics, and it did. In ancient Greece, a philosopher named Parmenides had argued that nothingness literally could not exist, that to speak of nothing was a contradiction because speech itself implies something. Early Christian theology took this further, associating the concept of zero with evil, with absence of God, with danger. Zero was feared and suppressed in parts of the Western world. India had no such fear. India embraced zero. And when Indian mathematicians formalized the concept, giving it a symbol, giving it positional value, making it a working part of a number system, they changed the trajectory of human intellectual history. The number system used across the entire modern world today is called the Hindu-Arabic numeral system. The Hindu part of that name is not decoration, it is acknowledgement, however indirect and understated, that the system originated in India. In the 5th century, before the Common Era, a Greek philosopher named Democritus proposed that matter was made of indivisible particles. This idea is celebrated in Western history as the origin of atomic theory. But in India, a sage named Acharya Kanad proposed essentially the same idea, possibly earlier and with significantly more detail. Kanad's account of his discovery has a quality that feels almost too human to be mythology. He was sitting by a river, eating a handful of rice, and found himself breaking each grain smaller and smaller, wondering how far the process could go. At some point, he concluded the breaking had to stop. There had to be a smallest possible unit, something so small it could not be divided further. He called it the paramanu, the atom. But Kanad did not stop there. He went on to propose that these paramanu, these atoms, could combine with each other in specific, predictable ratios to form larger structures. He called these combinations dwinuka. In modern chemistry, this is called molecular theory. Kanad was describing molecular bonding more than 2,000 years before John Dalton formalized atomic theory in the early 19th century. He was working with a conceptual framework that modern physics has largely confirmed, not through ritual or mythology, but through systematic philosophical reasoning applied to natural observation. And while Europe was still debating whether the Earth was flat and surrounded by crystal spheres, Indian astronomers were doing something else entirely. The Sanskrit word for Earth is bhugala. Bhu means earth, gola means sphere. Ancient Indians did not have a word for flat Earth because the concept was not part of their cosmology. The Earth was understood to be spherical, a globe, at a time when this understanding was considered dangerous heresy in parts of Europe. Astronomers like Aryabhata and Bhaskara went further than simply knowing the Earth was round. They calculated its circumference using mathematical techniques involving gnome and shadow sticks and advanced trigonometry. No telescopes, no satellites, no modern instruments of any kind. Their results were roughly 99% accurate. They also understood that the moon does not produce its own light, that it is a reflective body, shining because sunlight strikes its surface and bounces back toward Earth. This understanding, which seems obvious today, was revolutionary when it was first described. And it was described in India long before it became accepted knowledge in the Western world. Aryabhata also calculated the length of the solar year with remarkable accuracy and had a sophisticated understanding of the mechanics of solar and lunar eclipses, explaining them as the result of shadows rather than supernatural events, at a time when eclipse superstition was causing widespread panic in other parts of the world. These were not priests making guesses. These were scientists doing mathematics. Think about the university as a concept, a place where people gather specifically to learn, not as apprentices to a single master, not as religious initiates in a temple, but as students pursuing knowledge across dozens of different disciplines under one roof. A place with lecture halls, a library, dormitories, and a faculty of specialized scholars. Where did this idea come from? It came from India. Takshashila, sometimes called Takshashila in its anglicized form, is estimated to have been established in the 5th century before the Common Era, making it approximately 2,500 years old. It is widely considered the world's first university in the modern sense of the term. The scale of it is staggering. 300 lecture halls, a dedicated library, a tower built specifically for astronomical research and observation. More than 10,000 students at its height, drawn from as far away as Greece, Arabia, and China. Over 200 faculty members, including scholars whose names still echo through history. Panini, the Sanskrit grammarian whose work on linguistics has been called a masterpiece of human intellectual achievement. Chanakya, the political philosopher whose treatise on statecraft, the Arthashastra, remains studied in political science programs to this day. And the curriculum, 60 different courses spanning science, mathematics, medicine, political theory, astronomy, music, philosophy, theology, and military strategy. This was not a religious school. This was not a narrowly focused training institution. This was a university in every meaningful sense of the word, a place dedicated to the pursuit and transmission of knowledge across the full breadth of human inquiry. While other parts of the world were figuring out how to organize a functioning village, India had already built a global center of higher learning. The practice of yoga is, by now, known across the entire world. Yoga studios exist in small towns in rural America, in apartment buildings in Tokyo, in community centers in Lagos. Yoga is a billion-dollar global wellness industry. It is practiced by professional athletes, corporate executives, rehabilitation patients, and elderly people in parks. The word itself has entered virtually every major language on Earth, and it came from India. But what the global yoga industry rarely communicates, what tends to get lost somewhere between the branded leggings and the morning smoothie, is the sheer depth and sophistication of what yoga actually represents. In 1985, a researcher named Herbert Benson and a small team of scientists traveled to a Himalayan monastery for a study that, by any reasonable measure, should have made international headlines. They found monks practicing a specific yogic technique called tummo, a form of internal heat generation, in conditions that would kill an unprotected human being in hours. At altitudes of nearly 5,000 meters, in temperatures of minus 20 degrees Celsius, these monks would sit almost entirely unclothed and begin to meditate. The team measured what happened to the monks' bodies. Sweat began forming and evaporating from their skin, so much of it that wet sheets placed over their shoulders would steam and dry repeatedly throughout the night. The monks' core body temperatures remained stable. They slept peacefully on bare rock in conditions that should have been fatal. The scientific explanation remains incomplete, but the observable facts were documented, filmed, and published. This was not performance, this was mastery. The Indus Valley civilization left behind seals, carved images pressed into clay, that show human figures seated in postures that any modern yoga teacher would recognize immediately. The cross-legged position, the straight spine, the deliberate placement of hands. These seals are 4,000 to 5,000 years old, which means that by the time the Indus Valley civilization was carving these images, yoga was already an established, mature practice. It had been developed, refined, and passed down long before anyone thought to record it in image or text. And their contemporaries, the Mesopotamians, the Persians, the Egyptians, have left behind no comparable record, no evidence of similar practices, no understanding of the body as an instrument capable of this kind of disciplined, deliberate internal control. While other civilizations were building empires through conquest, one civilization in the Indian subcontinent was building something far harder to achieve: mastery of the human body itself. Among the most extraordinary physical structures in all of human history stands a temple in Konark, in the eastern Indian state of Odisha, the Konark Sun Temple. Built in the 13th century of the Common Era, it is designed in the form of an enormous chariot drawn by horses, with the sun god seated at its center. The entire structure is aligned with stunning mathematical precision to the movement of the sun across the sky. But the wheels of the temple, 24 large stone wheels arranged along its base, are not merely decorative. They are functional sundials. Each wheel is divided in such a way that by observing where the shadow of the central spoke falls across the carved beads at the wheel's edge, a person standing beside it can determine the time of day to the precision of a minute. Not to the nearest hour, not to the nearest half hour, to the minute. And this works not just during daylight. The positioning and design of the wheels allow time calculation at night as well, using moonlight and the known positions of stars. In the 13th century, using stone, with no mechanical components, no springs, no gears, no electricity, no software. The entire temple complex is essentially a 13th-century-old computing instrument, built from sandstone and aligned with the astronomical knowledge of scholars who understood the sun's path so precisely that the first rays of light at dawn would strike the feet of the deity inside the inner sanctum every single morning. This was not religion alone. This was engineering. This was science. This was a culture that saw no contradiction between spiritual devotion and mathematical precision, because for them, the two were part of the same search for truth. In the 14th century of the Common Era, a scholar named Sayana was writing a commentary on the Rig Veda, one of the oldest texts in human literature. In the course of that commentary, he made a calculation. He wrote that the light of the sun travels a certain distance in a certain unit of time, using traditional Indian units of measurement, the yojana and the nimisa. His statement was a reference embedded in a text about ancient scripture, almost offhand in its placement. When modern researchers converted those ancient units to contemporary measurements, they arrived at a figure of approximately 300,000 kilometers per second. The actual speed of light, as measured by modern science, is 299,792 kilometers per second. Sayana's figure, converted from 14th century Indian units, is accurate to within a fraction of a percent. The first Western measurement of the speed of light was made by a Danish astronomer named Ola Rømer in the 1670s. Sayana wrote his figure 300 years before that. Whether this represents an independent calculation, the preservation of older knowledge, or something else entirely remains a matter of genuine scholarly debate. But the number is there, in the text, written in the 14th century, and it is correct. There is a stepwell in the Indian state of Gujarat called Rani Ki Vav, the Queen's Stepwell. It was built approximately 1,000 years ago and was forgotten for centuries, buried under layers of silt deposited by a flooding river. When it was excavated and restored in the 20th century, archaeologists and engineers found themselves standing in something that defied easy description. It is not simply a well. It is not simply a structure. It is a 7-story building constructed entirely underground, descending in steps and galleries from the surface down to the water table, elaborately carved with thousands of sculptures, and engineered with a sophistication that challenged the understanding of modern civil engineers. The water management system built into it could store millions of liters of water and, through its underground positioning, keep that water cool even in temperatures of 45 degrees Celsius in the surrounding desert. 1,000 years ago. No refrigeration, no mechanical pumps, no modern materials, just an understanding of earth, water, stone, and mathematics so deep that the result was an air-conditioned underground reservoir that still functions today. The engineering required to construct a 7-story subterranean structure that does not collapse under the enormous pressure of the earth surrounding it. And that does so while remaining aesthetically extraordinary. Every wall covered in detailed carvings is a challenge that modern architects approach with awe. The people who built it had neither the tools nor the materials of the modern era. They had something harder to replicate. They had knowledge. This part of the story is harder to tell, not because the facts are absent, but because they sit at the edge of what recorded history can comfortably contain. The ancient Indian epic known as the Mahabharata describes in considerable detail a weapon called the Brahmastra. The description is precise in ways that feel wrong for their age. An explosion of light described as the equivalent of 10,000 suns. Winds so powerful that they level everything within range. Fire that burns not just in the moment of impact, but for a sustained period afterward. Survivors reporting that their hair and nails fell out in the aftermath. Land rendered barren and unproductive for decades after the weapon's use. The hair and nails falling out. The barren land. The sustained burning. The blinding flash. These are the exact symptoms and aftermath documented in survivors of modern nuclear events. Robert Oppenheimer, the physicist who led the development of the first modern nuclear weapon, a man who had studied Sanskrit and was deeply familiar with the ancient Indian texts, was asked shortly after the first atomic test in 1945 whether that explosion had been the first time a nuclear device had been detonated. His answer was not a simple yes. He said yes in modern times. Oppenheimer, one of the most brilliant scientific minds of the 20th century, left a door open in that answer. He did not dismiss the ancient texts. He acknowledged implicitly that the question of what humanity might have known and done in its distant past was not one he was prepared to close with a clean and comfortable denial. The Mahabharata also describes another weapon, the Pashupata, with capabilities that sound, in modern military language, like a precision-guided munition. Something that once launched could not be recalled. Something that did not travel in a straight line, but could track and follow its target. Something capable of eliminating an entire fighting force in a single deployment. Military historians who have studied these descriptions have noted, with obvious discomfort, that the descriptions of the weapon's behavior are more consistent with modern guided missile technology than with anything that could be explained as primitive imaginative fiction. Either ancient Indian writers had extraordinarily specific imaginations about technologies they had no rational basis to conceive, or they were describing something real. The question does not have a comfortable answer, but it is a question that deserves to be asked. Standing back from all of this, looking at the full picture, diamonds, buttons, sanitation, sugar, steel, surgery, zero, binary mathematics, atomic theory, astronomy, cotton, universities, yoga, architecture as scientific instrument, the speed of light, calculated centuries before the West. This is not a complete list. This is not even most of the list. The breadth and depth of what India contributed to the foundations of human civilization is so vast that a single documentary cannot contain it. Scholars have spent entire careers on single items in this inventory and still not exhausted what there is to know. And yet, ask a child in almost any country in the world to name 3 great ancient civilizations. Ask them to name the inventors of the things they use every day. Ask them where the ideas that shaped the modern world came from. They will name Greece. They will name Rome. They will name Egypt. They will name England. Very few will name India. Not because India wasn't there, not because India didn't do these things, but because for over 2 centuries, a specific set of decisions was made about whose history would be taught, whose contributions would be celebrated, whose intellectual achievements would be written into the standard story of human progress. India was systematically excluded from that story. Its manuscripts were burned. Its educational institutions were dismantled. Its traditional knowledge systems were dismissed as superstition. Its artisans were undercut by imported factory goods. Its scholars were told that real knowledge came from Europe, and that their own traditions were backward, primitive, and unworthy of serious study. It was one of the most thorough and deliberate acts of cultural erasure in recorded history, and it largely worked, for a time. But here is where the story turns, because India is still here. The civilization that gave the world its number system, its surgical techniques, its metallurgical innovations, its understanding of atomic structure, its first university, its most fundamental mathematical concepts. That civilization did not disappear. It was bruised, it was battered, it was deliberately diminished, but it did not disappear. India is still here, with a population of over 1 billion people, with one of the fastest growing economies on Earth, with a space program that landed on the south pole of the moon when no other nation had managed it, with scientists, engineers, mathematicians, and physicians making contributions to global knowledge in every discipline. The people who built the iron pillar that still stands without rust after 1,600 years, their descendants are writing software, launching satellites, performing surgery, and doing mathematics that pushes the boundaries of what humanity knows about the universe. The thread has not been cut. It was pulled and stretched and tested nearly to breaking. But it held. And now India is pulling it back. There is a generation growing up in India right now that is beginning to look at its own history with fresh eyes. Not with the gaze of people who were told their past was primitive and shameful, but with the gaze of people who are discovering, piece by piece, what their ancestors actually built and thought and created. And that rediscovery is happening at a moment when India is simultaneously stepping forward as a major force in the world's future. That combination, the recovery of memory and the assertion of possibility, is extraordinary to witness from the outside. It looks like a giant waking up. It looks like a civilization remembering who it actually is. You've just seen a fraction of it, a handful of chapters from a story so vast, so deep, and so systematically buried that most people can pass through an entire lifetime of education without ever encountering it. The mathematics, the medicine, the astronomy, the engineering, the philosophy, the mastery of time, water, light, and the human body itself. These were not isolated sparks of brilliance. They were part of a continuous civilizational current, refined across centuries, debated in universities, recorded in texts, tested in practice. India did not merely contribute to the modern world. India helped lay the intellectual foundations beneath it. And yet, ask almost anyone on the street where modern knowledge began. Watch their face go blank. Watch them instinctively reach for Greece, for Rome, for Renaissance Europe. That reaction is not random. It is not simple ignorance. It is the outcome of centuries of selective storytelling, of narratives that elevated some civilizations as sole torchbearers of progress while quietly absorbing the contributions of others. But erasure is not the same as destruction. Knowledge once created does not disappear so easily. It travels. It adapts. It survives in manuscripts, in translations, in borrowed ideas that reshape the world. The civilization endured. The intellectual tradition endured. The people endured. And today, in laboratories, universities, technology firms, space agencies, research institutes, and operating rooms across the globe, that lineage continues. The descendants of those who formalized zero, who mapped the heavens, who advanced surgical practice, who debated the nature of reality itself, are still building, still questioning, still shaping the future, still here. If this shifted something in how you see the world, don't let it end here. Share it, talk about it, read further, challenge what you were taught. Because history is not just about the past, it shapes who we believe we are and what we believe we are capable of becoming.